Hello class, we're going to be going over chapter 8. This chapter covers the idea of iterative statements. So in Java, we're going to learn the three different ways of looping, of iterating: the while loop, the for loop, and the do while loop. And we're also going to talk about nested loops. In programming, it's essential to be able to repeat instructions over and over again. We don't want to be typing, print hello 100 times. We want to be able to print it, write it once and to have some mechanism of repeating that. So that idea is this idea of iterating or looping, and we have three ways. We have the for loop, the while loop, and the do while loop that we're going to talk about one by one. Let's start off with the while loop. The while loop is very similar in syntax to the if statement in Java. It's just, we use the while keyword right here. We have a Boolean condition within parentheses, and then we have the body of the loop, which is the bunch of statements that we want to repeat. Now we enter into this while loop and we evaluate the condition, and if it happens to be true, then we execute each of these statements one by one. When we get to the bottom, we come back to the top and we test the condition again. If this is true, we repeat all the statements again. Only when it's false do we exit out and stop looping. Now, it is possible that the very first time that we come down into this while loop that this condition is false. If this is the case, then these statements are not executed at all and we just continue on. Now, we could also have a situation where there's only one statement that we want to repeat, and in that case, we don't need to have these curly brackets here. Okay, here's an example. We're going to look at a function called int log2 of x, where we want to find and return the value of the smallest n such that 2 to the power of n is bigger or equal than x. And so what we're going to do is we're going to create this variable p that starts with the value 2 to the 0. And then we're going to initialize n to 0. And then we're going to test this value of p. If it's less than x, which is our 2 to the n, right? If 2 to the n is less than x, we're going to multiply that value by 2. So the first time it's 1, then it's 2, then 4, then 8, every time we loop around here. So eventually, this value, this p variable, which represents 2 to the n, will be bigger than x. And once that happens, we stop looping and we return the value of n. Now notice there's this initialization phase where we have to initialize the loop variable. There's this testing phase where we test the condition of looping. And then there's this change phase where we have to change the condition such that at some point we stop looping. If we make a mistake here and don't have it, we end up with an infinite loop because there's nothing that will change the condition and make us stop looping. So again, just remember three pieces. And start by initializing some looping condition, test it, and then change it within the loop. Now sometimes the change of the variable is not obvious. It could be in a ways hidden or implicit. Now here's an example where we have what's called a scanner object, and a scanner object is basically a sequence of characters. And then what we're doing is we're saying, is there another character? So this has next method returns a true or false if there's more characters in this sequence of characters. If there is, we're going to get that next character using the next method. And so what the next method does is it returns that character and takes it out of that sequence. And then we come back up here to see if there's more. Okay, and this just loops around. And you notice that it's not obvious that it's changing, but it is because the next method will at some point cause the has next to be false. Okay, there's this word or this phrase loop invariant, and it's a word that you need to know. What it means is there is some true statement that can be said at the end of every loop that is executed. So what is the loop invariant of this piece of code? it's saying the loop invariant is that p is equal to 2 to the n. So at the very beginning of the code, before we even get into the loop, n is 0, and p has the value of 2 to the 0, i.e. 1. And every time we execute this, we're multiplying p by 2 and incrementing n by 1. So at the very bottom right here, this is always a true statement. And by understanding the loop invariant of your loop, it will actually help you understand what the code is doing. So it's important to kind of understand what that loop invariant is when you're reading code. Okay, the for loop is the second method of iteration in Java. What we do is, it's actually like the while loop. In fact, anything you could do in a while loop, you can do in a for loop. And what we do is, we write all three pieces, the initialization piece, the condition piece, and the change piece, all within one line. And so what happens is, step 1, we do the initialization expression. Then we do step 2 and evaluate the condition. If it is true, we end up executing all the different statements. Then we go and execute the change expression, and then go back to step 2, and this is our loop. Eventually, the condition will be false, and then we exit out of the loop. Now, Java also allows us to declare the loop control variable as part of the for statement itself. So you notice here, notice in the previous case, p was declared outside. But in this case, we're declaring this variable I within the for statement itself. And when we do this, this variable I is only understood inside the for loop. If we were to write outside of it, something like print I, we'd get a compiler error because it would say it has not been declared yet. So it's only known within the body of the for loop. Okay? Now, there are some important patterns that you need to recognize. When you see I is equal to 0 and I is less than n, we know the following. We know that I begins at 0, increments by 1 all the way up to n minus 1, and what that means is we are iterating n times. Now, we could also start with a value of 1, so count is equal to 1, and then we increment by 1 all the way up to n, and of course that will also be a loop of n. So in either case, we start at 0 and we see this less than sign, or we start at 1 and we see this less than or equal sign. In both cases, that means we're iterating n times. This is a very important kind of pattern to recognize, so that when you're reading code, again, on the AP test, when you see this code, you can just instantly say, oh, I recognize the pattern. That means it's a loop of n. Okay, here's an example of factorial using a for loop. And what we want to do is calculate the factorial of n. And so if I have n is equal to 4, I want to calculate 1 times 2 times 3 times 4. Now, if I'm creating this program, I notice that, I want to multiply these numbers together. And so I'm going to use a loop to do this multiplication. So what I'm going to do is I'm going to start by initializing f to be 1. That's what you see right here. And then within the loop, I'm going to then multiply it by 2, and then by 3, and then by 4. So I'm going to use a variable k. And I'm going to initialize that to 2, because that's the first number I want to multiply f by. And then I'm going to increment that by 1 until I hit the ending value when k is equal to n. So by doing this, initializing at 2, testing if k is less than or equal to n, and incrementing k by 1 each time, at the very end of the loop, I will have accumulated this 4 times 3 times 2 times 1 number. Okay, third method of looping is called the do while loop. And the only difference between this and the while loop is that we have the while condition at the end. And what that means is we know for a fact that we will always execute the loop at least one time. Then we check the condition to see whether or not to continue looping. And if it's false, then we just exit out. Now, by convention, it's just good practice to put the curly brackets here, regardless of whether there's one or multiple statements. It just makes it more readable. So here's an example. In this case, we know we want to execute this at least once, and so that's why we start with the do. So we're reading a line from this file, and then we keep on going as long as what we read is not a null value. Okay. Now, we could turn it into a while loop if we wanted to, and what we would do that, if we know that we always want to execute this one time, we want to make sure that the first time the condition is false. So we can initialize this str variable to some dummy value such that the very first time it's guaranteed to be false, and so we always execute this at least one time, and then we begin our loop. Now there are two different ways Java allows to break out of the loop, I'll say prematurely, even though we haven't hit the condition of stoppage. We have what's called the break and we have the return. Now the difference between these is the following. The break will break you out of the loop, but will stay inside of the function or method that you're in. Whereas the return statement will both break you out of the for loop, but it'll also break you out and return back to the calling function. Okay. Now, the break or the return should always be within some sort of if-else type of statement. Otherwise, there's really no reason to have the break or the return. Let me describe what I mean by that. So we have a while statement, we have some sort of condition, and then we have some statements inside, and then suppose we just decided to do a break right here. And then we have, say, two more statements underneath. Well, the very first time we're inside the loop, we execute these lines, we hit the break statement, and the break will actually kick us out of the loop. And so these statements right here will have no use. They will never, ever get executed. There's no purpose. So it makes a lot more sense, really, to do something like this, where we would actually put the break statement inside of a condition. So we say, if some condition exists, then break and leave. Otherwise, continue on with these statements and then maybe continue looping as well. Okay, so here's an example of that. This is an example where we're trying to find the largest value, the largest divisor of a value, of a number n. And so we're going to start with n minus 1 and just work our way down, testing, is n divisible by d with a remainder of 0? If it is, break out of it. Okay. Now, here's an example where we're breaking out of the loop with a return. And in this case, what we're doing is we're going to be searching for some word within a whole list of words. And we haven't seen arrays yet, but basically it's just a whole bunch of words that we can index with an integer. And so we can access the 0 element and the 1 element and the 2 element. And so we're going to check one by one. Is this word equal to the 0 element? Is this word equal to the element 1? Is this word equal to element 2? And once we find that they are equal to each other, we will return that value at which we found the match, and we'll exit out of this method completely. If after looping through this entire thing, we never found anything equal to each other, we will then exit out here, and then we'll return the value -1, which means that, oh, I didn't find a match. Okay, nested loops. Nested loops are very important structures where we have a loop inside of a loop, and it's very useful, for example, when we want to iterate within a two-dimensional array. And you can almost be guaranteed you'll see this on the AP test. So let's see how this would work. Now, first thing I like to do is I like to see what is this loop doing, and I see that the statement that really does work is this fill rectangle. And basically what it's doing is it's drawing a little 8 by 8 square. And so you can see this is one call of this fill rectangle where it draws one square. Now you see here, so then now that we know that, okay, we're just doing a lot of square drawing. So then we have to think about, well, how is it doing it now? So let's look at the outer loop. And the outer loop is starting at an x value of 0, then it's incrementing by 10 until it hits the value of 40, and then once it hits 50, it stops. Okay, then let's think about what happens with the y value now. So once we start off with x equals 0, then we go into the inner loop, and with the inner loop, y starts with a value of 0, then it goes to a value of 10, then 20, and then it stops. It doesn't hit 30, or it breaks at that point. So you can imagine that with the x value of 0, we're drawing a square once, then another square again, then another square again at these different y values. So in this picture up here, at x is equal to 0, you can see that we have these different values of y here, where we're drawing successively this square first, then this square, then this square. Then x gets bumped up to 10, and then we draw these squares, and we loop again. We loop again in the inner loop, and then we loop again in the inner loop. So eventually we do all of these squares here, and so the outer loop is this, you could say, the horizontal piece, and this inner loop is this vertical piece in the y direction here. So it's important that when you see this, nested loop, you can imagine how is it being drawn? What's the sequence? Is it going across or is it going down? In this case here, because y is our inner loop, it's going down, 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 down. Now, in that previous example, these braces were not really necessary because there's only one statement inside of this for loop. And as well, there's only one for statement within this loop as well. So the curly brackets are not necessary, but it's kind of nice to put in, I think, for readability. Now, be careful when we break out of a nested loop. In this example here, this break statement will break out of this for loop, but it doesn't mean that we break out of this loop here. It does not mean that we jump from here all the way down here. It just means that we break from here to here, and then we come back up here to the outer loop to go again. Now there's this pattern of a triangular nested loop as well, and this pattern is another important pattern to just recognize, because it's going to help you on, again, the AP test, just to recognize it and understand what it's doing quickly. Notice that this loop is a little different because J is based upon the value of I. Let's kind of work this out a little bit. Let's suppose the length happens to be 4, just to kind of make it somewhat easy and small. Okay, so I is going to start out at a value of 0. J is going to be I plus 1, so it's going to start off as 1. And it's going to increment to 2, and then to 3, and it's going to stop at 4, because at that point it's going to break out of this loop. Then we go back to the outer loop, increment I to 1, and J this time will be 1 plus 1. So J will start with the value 2, then it'll go to 3. Then I will go to the value of 2, and you can see that this will start at 3, and then that's it. And then I will then go to 3, and J will go to 4. But the interesting thing here, J will start at 4, but 4 is not less than 4, so this the statements inside the for loop don't even get executed. So in a sense, this doesn't really happen. So all that happens is this stuff right here. And you can imagine if this were some sort of kind of two-dimensional array, you can imagine that it's iterating through these pieces here, something like that. So some sort of triangular pattern, you could imagine it, or actually maybe more like this. Something like that. Some sort of triangular pattern is being kind of filled up. Okay, so I'm going to finish out very quickly here just by opening up these, but what you should probably do is think about these as I click on the boxes, okay? So you can pause it here, read it, pause it. And actually for this one here, nested loops are really good for two-dimensional arrays, pictures and stuff like that. Okay, that's it for today. Have a good day, everybody.